Hello dear students, welcome you back for lecture number 8 on the topic system of particles and rotational motion. So in today's class we are going to study two important theorems, that is perpendicular axis theorem, and along with that also we are going to study parallel axis theorem. Now the significance of both the theorems is to find the moment of inertia. So in earlier classes we have already found moment of inertia, but it was for very simple body structure. Now these both theorems will help you to find moment of inertia of any complex structure. Okay, so let us understand both the theorems. I will derive the expression for perpendicular axis theorem and also for parallel axis theorem. We'll try to understand both the theorems, and probably in the next class we'll be solving the sums on both the theorems. If time permits, we'll try to solve sums today itself. Let us see how it goes. But first let us understand what is perpendicular axis theorem. So write the statement along with me. It's quite a big statement. So it states that moment of, see again the name itself is perpendicular, something to do with 90-degree axis. Definitely axis, it's a rotational motion, we have to consider axis of rotation, and theorem is something to do with the proof. So moment of inertia, it states that moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to sum of moment of inertia of any two mutually perpendicular, sum of moment of inertia of lamina, you write, lamina of any two mutually perpendicular axis, in its plane, and you can stop here also, but let me write, and intersecting each other at a point, where the perpendicular axis passes through it. So that's a statement. Okay. Quite a big statement, but very easy to understand. What it states: moment of inertia of plane lamina about an axis perpendicular to its plane is equal to sum of moment of inertia of a lamina about any two, just write, I forgot to write lamina here, of lamina about any two mutually perpendicular axes in its plane and intersecting each other at a point where the perpendicular axis passes through it. First note it down, then later I'll explain. Once you note it down, you will get a hint of idea. So what they are telling basically here is, I'll erase some of the part here, intersecting each other, or else I'll try to explain you here only. Now first and most important condition you remember, this theorem is only valid for a plane object. Plane objects are 2D objects, or you call it as a lamina. Lamina is something, a plane sheet where the third dimension is neglected, a plane object. One more thing, here axis should be mutually perpendicular to each other. The conditions we'll study afterwards. I'll just try to explain you first what exactly the theorem is. Have you copied down? So like erase, so that I'll take the entire board to explain you. So please try to understand. Moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to sum of moment of inertia of lamina about any two mutually perpendicular axes in its plane and intersecting each other at a point where the perpendicular axis passes through it. I better suggest you write it. Once I erase, you can refer your notebook. Okay. So now let us understand what exactly perpendicular axis theorem means. You are expected to write the same definition in the exam because it's a theorem. So you cannot compromise with the statement. So imagine I have a random body. Okay. Now, what does perpendicular axis theorem tells you? Suppose you want to find moment of inertia about this axis, z axis. Moment of inertia about this z axis. So using perpendicular axis theorem, how will you find? Suppose if I consider this is my x axis, and if I consider one more axis, that will be my y axis, passing from this. This is my y axis. Now imagine it's a plane lamina. Okay, a plane lamina. Plane lamina in the sense it's a thin metal sheet. Okay, a 2D objects, a planar objects whose thickness is negligible. You can consider thickness is equal to 0. It will be very small. So suppose if you want to find moment of inertia of this plane lamina about this z axis, suppose it is rotating anti-clockwise about this axis. So if you want to find moment of inertia about this plane axis, so you put that into statement: moment of inertia about plane lamina perpendicular to its plane is equal to sum of moment of inertia of any two mutually perpendicular axes. Yes or no? Ix plus Iy. So this is a perpendicular axis theorem. So perpendicular axis theorem, what does it mean? If you want to find moment of inertia about z axis, so simply what you have to do, you have to find sum of moment of inertia about both Ix plus Iy will give you Iz. Yes or no? Mutually perpendicular. What does it mean? This is x coordinate, y coordinate, z coordinate. X and y and z are mutually perpendicular to each other. This is axis of rotation. Okay, it is rotating this way. This is axis about this z axis. Okay, mutually perpendicular in the sense what? The angle between x, y and z should be 90 degree. Okay, it should be 90 degree. So your condition is most important. First or most important thing, perpendicular axis theorem is only valid for 2D objects or two-dimensional objects, or you can call planar objects. Okay, or you can call lamina. One more thing, the axis Ix and Iy must lie on a plane. Must lie on a plane. Must lie on a plane. Okay. The next condition, x, y and z must be mutually perpendicular to each other. Mutually perpendicular to each other. And one more, z should be perpendicular to the plane. The condition is very important. Once you understand the condition, easily you will understand. Okay. Now some of the students, they might find difficulty in understanding. Don't bother. Once we solve actual problems on this, things will be very much clear. But right now understand ki suppose I take this book. Okay, this is a plane lamina. There is one axis, z axis going on. Okay, the marker, this is z axis. Okay, I take one more marker. Okay, z axis. So if I want to find moment of, and this book is moving in this direction, and if I want to find moment of inertia about this z axis, what I will take? I'll take two mutually perpendicular axes on this plane itself, x and y. If x is in this direction, y is in this direction. So if I take x plus Iy, that will give me value of Iz. Are you understanding? So the condition is most important. It should be a 2D object. Its book is 2D object. Its thickness is negligible. We will not consider the third dimensional. Ix and Iy should lie on a plane. So x and y should lie on a plane. Okay, X, Y and Z should be mutually perpendicular to each other, and Z must be perpendicular to the plane, and Z should be perpendicular to the plane. Have you understood? Got it? So how you get this? Iz equals to Ix plus Iy. So let us understand how did it came. Okay, so simple thing. You have to just add Ix and Iy, you will easily get the value of Iz. Okay, so we will try to derive this formula. How it came, it is very important to understand. Remember the condition, it is only valid for 2D objects. You cannot write it for 3D objects. You cannot use this formula for solid, sphere or cylinder, okay, or any hollow cylinder also. You cannot use for 3D objects. And one more thing, most common mistake student do is, since our x, y and z are mutually perpendicular to each other, right? It doesn't mean ki ix can be written as iz plus iy. No. The sum should be the plane, the axis which is on the plane. So x and y were along the plane and z was perpendicular. If this was the case, if ix is the perpendicular axis, then in that case you should write iy plus iz. Okay, so if I consider my first case, don't write ix equals to iz plus iy. Ix and iy both are lying on the same plane. Iz is perpendicular to the plane. So the sum of the planar axis is equal to the perpendicular axis. So I call it as perpendicular axis theorem. Doesn't mean you can write ix equals to iz plus iy, or you can write iy equals to iz plus ix. This is wrong, because z is perpendicular axis, iy and ix are parallel axis or planar axis. Got it? Okay. So now let us understand how did that came. Okay. Quickly we'll recall the things. Again, remember the same diagram. Okay. So this is my iz. I will take this as ix, and I cannot show the third object here, so I'll write it as iy. Okay. Now we'll try to derive this. So now, suppose if I take a small mass here of dm. Okay. The total mass of this body is m. And if I take the small mass at this point, dm, when I do total mass, I'm going to get m. So I'm taking a small mass here. So I will find what is the x coordinate from here and y coordinate from here. Are you understanding what I am trying to tell you? Got it? So what will be this distance? This will be x, and this will be what? Y. What will be this coordinate? X and y. See, please try to understand. Okay. I want to find moment of inertia of this small particle dm. So what will be the coordinate of this particle? X and y, right? Am I correct, right? Are you understanding? See here, from x, how much far it is? This much y. From y, how much it is? X. Are you understanding my point? See here, this is the body. These are the axes. You are finding here mass m. So what are the coordinate at this point? Is it not x and y? How it came, you see here? See here, if this is my x-axis, from x-axis how much y? This much y. Y is this, no? And from y how much x? This much is the x. So this much is the x, this much is the x. So coordinates will be x and y. Are you understanding? I hope you understood. The coordinates here will be x and y. X can be anything, y can be anything. We don't know exact number, so we are just taking the variable. Got it? Have you understood? Okay. So coordinates here will be x and y. So what will be the distance from this z-axis? You consider it as r. Have you understood? Okay, I'll take some more time to explain you this thing, because this sometimes it becomes difficult, okay, to understand for few students. Those who are understood, they can fast forward this thing. See here, I am finding mass m here. I want to know coordinates of this. Definitely it is x and y. All of you agree with this. How? You see here, from this is x-axis, this is my y-axis. From x, how much is the y? This much will be the y. Yes or no? This much is the y. From y, how much is the x? This much is the x. So at this point, x and y are the coordinates, and from z, this much will be r. Are you understanding? See here, from where you have to take mutually perpendicular and where they intersect, intersecting at a common point. So they intersect at this point. So you have to take from here only. It doesn't mean you can take from z-axis, you cannot take from here, you cannot take from here. You should take where they intersect. Remember the last line. Have you understood? Okay. Now let us put it. So for x, this much is the y. From y, this much is the x. Have you understood? Okay. So if I write moment of inertia about x-axis, how much it will be? Moment of inertia about x-axis, it will be dmy square. All of you agree with this? small moment of inertia. What D indicates? Small moment of inertia for this small mass. So dIx will be dmy square. Are you understanding? dm is this mass. See here, moment of inertia formula is what? mr square. What you want? You want moment of inertia about that small object. So small object means small moment of inertia, d. About which axis? X axis. From x how much? Y. So this will be what? dix will be what? M. From x how much is the distance? R. Here it will be y. Are you understanding? Since it is small mass, dm. Have you understood? Okay. Similarly, moment of inertia about y-axis. Small moment of inertia for this small mass d. So this will be what? dmx square. All of you agree with this? Got it? Fine. So for x, again, you want moment of inertia for y. I is equal to mr square. Since it's small moment of inertia for this small mass, this. So about which axis? Y axis. Y से कितना x है? This much x. So here will be x square. Got it? Okay. Now, similarly, what is diz? It is dm r square. Write it as equation number 3. What is the distance? R. Got it? Now, from this triangle, what is value of r? R is equal to r square is equal to x square plus y square. Can I write? See here, look at this triangle. This is x, this is y. Got it? So this will be what? R square can be written as x square plus y square. So now substitute diz equals to dm. Instead of r square, you write x square plus y square. So this diz will be equals to dmx square plus dmy square. Got it? So now see here, dmx square, what does it indicate? diz equals to dmx square. Is it not diy? What is dmy square? Is it not dix? So when I integrate this term, integrate, or you can do summation. In second year probably we will be studying integration. Integration means we just add them. So this is for small moment of inertia for this small mass. If I go on adding for everyone, so dm will give me total mass m. Similarly di will give me total moment of inertia I. So this will give moment of inertia about z axis. This will be iy plus ix, or you can write, you can just rearrange iz equals to ix plus iy. So is it not what the theorem tells us? So moment of inertia about z axis, which is perpendicular to this body, is equal to sum of moment of inertia about any two mutually perpendicular axis passing through a common point. Have you understood this? The proof of this? Okay, copy it down. So now next we are going to study is parallel axis theorem. So copy it soon so that we'll study parallel axis theorem. Okay. So next we are going to study is parallel axis theorem. Okay. So again the name itself suggests parallel axis theorem. Parallel, all of you know, two lines traveling in the same direction. Parallel axis theorem. Now what it states? Statement you write first. Moment of inertia, and write short for moment of inertia of a body about an axis is equal to sum of moment of inertia is equal to sum of moment of inertia parallel sum of moment of inertia about a parallel axis. You write about a parallel axis, about a parallel axis, sum of parallel axis and and product of mass, you just write product of you just write this parallel axis through its center of gravity. You write through its, this you write first, I was supposed to write it later. You write through its center of gravity, or you can write center of mass, doesn't mean difference, through its center of gravity. And now you write and product of its mass and square of distance between them. So please write the statement as it is, what is given in the notes or maybe in the textbook. Okay, you cannot manipulate the theorem, it's a law, it should be written as it is. So I was supposed to write this statement later, but no, since in the textbook they have mentioned it earlier, so you should write it. The meaning may remain same, but it is always expected to write this statement as it is. Okay, so parallel axis theorem, please try to understand, or when I explain, the things will be very much clear to you. Moment of inertia of a body. Imagine a body whose moment of inertia of an axis is equal to sum is addition of moment of inertia about a parallel axis through its center of gravity or center of mass. You know, I had told you the concept of center of gravity and center of mass. For small objects, the center of gravity and center of mass almost coincide. So doesn't make a difference if you write gravity or mass. And product of its mass and square of the distance between them, or distance between two axes, you can write distance between two axes. So what do you understand? Let me write it. It's mathematical form. Moment of inertia of a body about an axis is equal to moment of inertia of a body about is equal to sum of whose sum of moment of inertia about a parallel axis through its center of gravity or center of mass plus and product of here sum of moment of inertia about a parallel axis through its center of gravity or center of mass and product of its mass and square of the distance. So this is my parallel axis theorem. Please don't confuse yourself with perpendicular axis theorem. What is perpendicular axis theorem? Iz equals to Ix plus Iy. What is parallel axis theorem? I equals to ICOM plus MA square. What is ICOM? It's a one axis which is parallel to the axis which I want to find, but that axis should pass through its center of gravity or center of mass. You can write center of gravity or center of mass plus the product of its mass and square of the distance. That square distance you can take A or R. It doesn't make a difference. You can write A or R. Have you understood this? We'll try to understand. Okay, how does it came? Okay, so now first you'll write the conditions for this. Conditions. So what was the condition in perpendicular axis theorem? It was valid for 2D objects. Here it is valid for 3-dimensional objects. 3-dimensional object. Second condition, two axes must be parallel to each other. Which are the two axes? One axis which is passing from center of mass and one you are finding it. Both the axes should be parallel to each other, and one axis must pass from center of mass. So this is the condition. Okay, and that distance A, the distance A must be perpendicular to both the axes. Obviously it will be perpendicular, one axis, both are parallel, so this distance A will be definitely a perpendicular. So please remember the equation and the conditions. It is valid for 3D objects, it is valid for two axes. The two axes must be parallel to each other. Here they were not parallel, now here should be parallel. Now two axes, one of them the axis should pass from center of mass, and the whatever distance A you are taking, that should be perpendicular to the both the objects. Have you understood? Okay, now I'll erase this. So let us understand how did it came. Okay, we'll see how does that derivation came. Now, see here. Suppose again I'll take a random body. So now it's a parallel axis theorem. So it is very important that two axes must be parallel to each other. One of the axes should pass to the center of mass. Suppose this axis is passing through center of mass. Now using this parallel axis theorem, this can be a solid sphere also, okay, 3D object. Now using this parallel axis theorem, I want to find moment of inertia about this axis. Moment of inertia about this axis. Got it? So let this distance be A. Whatever distance I was telling you, let this distance be A. Okay. So now obviously it is initially the body was rotating about this axis. Now the body is also rotating about this axis. So definitely moment of inertia will increase or decrease. Moment of inertia will increase. Yes or no? Okay. Now suppose there is one small mass m here. Let me give it here only. dm. That mass is delta m is here. Okay. Now let me give a distance r from here. Okay. Now let us find di center of mass. Remember what we want to derive? I equals to I center of mass plus ma square. So let us see how it came. So I took a body, I took one axis. Very important, one of the axis should pass from the center of mass. So I'll assume that body has a center of mass here. Okay. And one more axis whose moment of inertia we are going to find, which is at a distance a. I'll take one small mass dm, which is at a distance r from my center of mass. So center of mass becomes my origin. Okay, as I told you, to find center of mass you should have an origin. So this becomes origin. So delta I cum will be what? dm r square. Equation 1. Yes or no? All of you know what is equation for moment of inertia? I equals to mr square. I equals to mr square. Got it? Have you understood this? So for this small object di will be what? dm r square. So they are at distance r square. Similarly, what will be di? What will be di for this small moment of inertia? For this. So this will be what? For this small object about this axis, moment of inertia will be what? dm r plus a the whole square. Is it not? Got it? Are you following? Have you understood? So this is my axis and they are away from a distance r plus a the whole square. Have you understood? This is for center of mass mr square. This is for this axis. So now you just solve this. Di will be what? dm a plus b the whole square. Have you understood this? dm r square. Here r square means the distance. R plus a the whole square. Have you understood? For this mass I am telling you. Okay, so r plus a the whole square, a plus b the whole square, a square plus b square plus 2ab. Okay, now open the bracket. Di will be what? dm r square plus dm a square plus 2ar plus 2ar. Have you understood? So di will be what? Once you integrate this, integrate. After integration I told you di. Similarly, if I take small mass dm here, dm will give me total mass m. Similarly, di will give you total moment of inertia I. So after integrating you will get total moment of inertia I. This will be what? mr square. So look at this, delta mr square. So before integrating only you can write it. Delta mr square will be what? Delta ICOM. Are you understanding? And delta not, sorry, DICOM. Are you understanding? So, or else I'll integrate in the next step. Okay, I'll integrate in the next step. Don't mind. Okay. So this will be what? dm r square. Instead of dm r square, shall I write DICOM plus dma square plus 2ar. So again integrate now. After integrating, what you are going to get? DICOM will get you ICOM, or you can write COG plus this will be what? Delta m will give you total mass m a square. So and this term is 0. Okay, you can ignore this term. 2m delta r, sorry, 2 dm AR. dm AR. Okay, this term is 0. I'll tell you why it is 0 also. First you understand. So have you understood the derivation for this? This is 0. Okay, have you understood? So this I wanted, right? I is equal to ICOM plus MA square. MA square. Have you understood? Okay. Now I'll tell you why it is 0 here, or else you will not understand here. Now see here. This is what dmAR. So integration of the constant should be taken out. 2 is constant, m is constant. What is left inside? dr by dr. Only thing left here is dr. Yes or no? Now, okay. So now what I will do here is, if I divide and multiply m, so what I am going to get here is delta m. I will not take this. Delta m r. Okay, delta m r. Okay. Now see here, students, I have simply written a here. Okay. So this a is also constant. Now see here, I'll tell you why it is 0. What I have done is, I'll erase this for you. Listen. Have you understood this? Or else I'll erase here and I'll explain you. Now look here, why it is 0. It is very important to understand. It is integration of 2 delta m AR. Got it? Now you know the rule of integration. Constant should be taken outside. So 2 is outside. A also remains constant. Since it's a parallel axis, distance remains constant. So what is left inside? Delta m R. Okay. So what I will do is, I will divide and multiply m on both sides. Divide and multiply m on both sides. So once I divide and multiply m on both sides, is it not a formula for moment of inertia? As I told you, moment of inertia is what? m1 r1 plus m2 r2 plus so on up to mn rn, divided by total mass m1 plus m2 plus m3 and so on. So look here, it is integration of dm r for small. So second will be dm r2, dm r3, dm r4 and so on. So m1, m2, m3 will give you total mass m. But fortunately, what is this r? This r is the distance, and about which axis we are taking? About center of mass. This is the origin, so definitely r will reduce to 0. So once r is reducing to 0, so 0 into anything will be 0. Okay, have you understood? In exam straight away you write a 0. Okay, need not explain why it is 0. You can stop it here. Okay, have you understood? Okay, so probably in the next class we will be doing some on this, or we'll do some more on the moment of inertia concept using the regular principle. Okay, thank you. We'll stop it here.